This time I prepared a grid for a breakout style game. So if I want to design my level, I could take these prefabs and then use the grid align panel, drag rectangular grid here, turn on auto snapping, and then start filling the scene with these blocks. Now that's one way to do it, but it's not the best way. There are several reasons why you shouldn't do it like this. For one, it's really tedious to take all these prefabs and then drag them around and then do it all over again for the next level. The other reason is if you want to load another level, you need to unload this scene, load another scene, and you have to manage stuff like background music and score, and you have to make sure it gets carried properly between levels, and it's just more work. Also, if you want to give players a way to design their own levels or provide DLC or just any user mods, it's really hard to do it if all your levels are saved as regular scenes. So what I'm going to do is instead is get rid of these blocks, and instead I'm going to write a text file which contains the information for our level. So if you see here, red, green, blue, and so on. And now I hit play, and the level builds itself based on this text file. So we can see red, green, blue, green, and so on. If I click try another level, I can load another level without changing the scene. So the computer just looks up another file and then builds the file based on this level. Builds the level based on this file. Sorry. And as you can see here, we have these blocks, and when I press try another level, all those blocks, old blocks get removed and I get new blocks. So if I keep pressing it, you see the scroll bar doesn't really change size that much. So in this tutorial I'll show you how you can write a simple text parser which will take this grid, a text file, and then place objects based on the contents of the text files inside these grid boxes. Before we get started, let's first take a look at what we already have. So I've prepared a grid. We render it from 0, 0 to 30, and I set spacing to x3 and y is 1, so x gives us how wide our blocks are. Let's go back to 3. So this is our template for what the grid will look like. Next thing we have here is three prefabs, just basic cubes with a certain size and a color, red, green, blue. And we have also our level files, which are just letters for which cube we want to use, and 0 stands for holes. So let's get started. First we create a JavaScript, and let's call it level text parser. I'm going to use JavaScript, although I would recommend C# in this case, because we are going to use .NET classes. So it's not only Unity3D we'll be using, but also .NET. And if you use C#, there is much more documentation available online. So let's open our script, and we won't be using any of these. Now, first thing we need to do is we need to store our levels somewhere. So I'm going to create a variable, public var level data, text asset, and it's an array, so we can store several levels in one variable. Then we also need a place to store our prefabs, public var red cube of type game object. If you have a prefab, there are several types you can use, for example transform, but we'll use game object and you will soon see why. We also need our grid. I'm going to set it as private because we just need it once and we don't need it publicly accessible. Now we come to text parsing. So in order to parse our text, we need a string reader variable. I'm going to call it reader. And string reader is a .NET class. So we can't use it just like that. We need to import a certain namespace. So we'll go to the start and say import system.io. If you don't know what it means, just use Google search C# .NET system.io or something. Essentially we need it so we can use our string reader class. We also need a counter that says which of these certain levels we are using, and we'll always start with level 0. Of course you can change it if you want for your game. And in order to unload the level, we also need to track which blocks we've already placed last time. So I'm going to store these blocks in a list. The list is a generic list of type GameObject. So in order to use generics, we need another namespace. We need import system.collections.generic. So what these brackets do is they tell us our list can only contain entries of type GameObject. And the reason I'm not using just any list, but a generic list, is because generic lists are generally faster than normal lists. Now let's take a look at our functions. So we need an awake function that sets everything up. We need a function that builds our level, so function build level, and it takes the following argument. It takes level data of type text asset, and it takes a level grid of type gf rectangular grid. So it takes the text file, reads it, and then aligns those blocks along our grid. And we'll also create a function to create a block, and takes the following arguments. It needs the letter, and letter will be of type character. So it's not a string, it's a character, a char. So a string is just a bunch of characters, and each of these characters is of type char. And we also need a target position of type vector3. And that's the position where our block will end up. Now let's start filling these functions. So first thing first, we need to set up everything. Level grid is getComponent gf_grid, standard stuff. Blocks is a new list of game objects, which will be empty at first, but we'll fill it later. And build level calls a first time our level builder, and it uses our current level, which by default is 0. We could of course change this if we wanted, but I've set it to private and 0 just for sake of demonstration, and we use our level grid, which is the only grid we have. Now let's get to the really meaty part. So first of all, if we have no prefabs defined, so if not red cube or not green cube or not blue cube, we just return, so we don't get any errors. Now we need to set up our reader. So first thing, we take our reader variable and create a new string reader, which will take the text of our level data. Next thing we do is we read the first line of our text file, so reader.readLine equals line, which is of type string. And we also need a way to keep track of our row, so we can descend. So essentially what I'm going to do is I read one line, fill it, and then descend one row, and then fill that row, and then descend one more row, and so on, until I've reached the end. So we also need to keep track of our rows. So now we can start reading. So I say while line not equal null. We'll keep reading and building. So now we have a line, and we need to take this line apart. So I'm going to create another loop for var I equals 0, and it's of type integer, and while I is less than line dot length, and we'll reach incrementation, we increase it by 1. So in this case, what I'm doing is I'm going to loop that line. Just a moment. So I'm going to take this line and then go character by character. R, G, B, G, and so on. So line length gives me the length of this line, so how many characters are in this line. So we need our target position, which is a type of vector free, and it's level grid to world. So we take grid coordinates and transform them to world coordinates of I, our position in the horizontal, plus 0.5 because we want it at the center of the grid, not at the edge. And then minus rho because we are descending. We are not going upstairs, we're going downstairs. So we need, when our row is 3, we don't go 1, 2, 3, we go -1, -2, -3. Again, minus 0.5 because we wanted the center. And here comes our Z position, and I'm just setting it to 0 because we want all our blocks to be on the same Z-axis. Okay, now that we have our target position, we can create a block. Create block using line I. So line I is character at the ith position. So if I is 3, then it would be G. And we take our target position. And that's it for this loop. Now we can increment our row plus plus, and we read the next line. Line equals reader dot read line. And that's essentially all we need to pass our text file. So again, to summarize, we create a new reader, we store our lines in a separate variable, we keep track of our row, and then for each line we go character by character, decide the target position based on the character's position inside the text file, and take this position as grid position, transform it to world position, and then pass it to create block. Now obviously we need to fill our create block function with life. So first create a variable for our cube of type GameObject, and it will be null by default. Next thing, we need a switch based on the letter we passed. Currently we have 3 cases in our example, so case R. And for characters, we don't use these double quotes, we use these single apostrophes. So if you use these, then it will be a string. But we don't have strings, we have characters. In that case, our cube is red cube, and we are done. Break. The other 2 examples work the same. So in case of G, we have our green cube and so on. And we also have a 4th case, case default, no case in this case. So if we have neither R nor G nor B, we'll just use break, and in that case we don't create any block, it's just an empty hole. And in our level file I've used 0, but I could have used anything like P or whatever. Doesn't really matter, as long as it's not R, G or B. So if we have our cube, so if cube, then we obviously want to instantiate it. And we'll use a variable in this case, you'll see soon why. var obj equals of type GameObject is instantiate cube target position quaternion identity. Quaternion identity is its rotation, and it's the default rotation as type of GameObject. Now, why would I want to give it a variable? As I've said previously, we need to keep track of our blocks and what blocks we've instantiated, so we can remove them when we load another level. If we didn't do this, then all those blocks would stack, and if you switch to your scene a few times, you'd have like 100 blocks, even though you just want like 20 or something. So we need a way to register our blocks in this list and then delete the list before we generate a new level. So if we go here, I'm using my variable blocks dot add obj. So now we have a way of filling our list. We also need a way of emptying it. And the best way to empty it is when building a new level. So I'm going to insert it here. For var go of type game object in blocks Now I'm going to loop through every entry in blocks, and I need to make sure there actually is a gamed object, it's not just a hole, or it hasn't been destroyed already during gameplay. So if go, then destroy go. Okay, this will destroy our blocks, but it won't delete the reference in our list. So our list is now full of null object references, which obviously don't do anything, so we need to clear our list. So just call blocks.clear, and your list should be empty by now. And now we can start building our new list. Let's hit save and see if we get any errors. Okay, that should be it. Now let's go back to our grid object and assign our level text parser script. We set our size of level data to 3, and we carry these. And we drag our prefabs. And let's hit play. And we see it gets filled up. Now, as an extra touch, I'm going to add a little button. Function on GUI, if GUI button rectangular blah blah. You get it. Current level equals current level plus 1. Modulo level data length. It's a little math trick. We increment our current level index, and then we perform modulo level data length, which means once we exceed the length of our array, it will jump back to 0. So if we have 3 arrays, it goes. If we have 3 entries, it goes 0, 1, 2, 0, 1, 2, 0, 1, 2, and so on. It goes in circles. And then we call build level data current level, which is the level we've picked next, and our level grid. So let's hit save, hit play. And we can try always another level. And as you can see, all blocks always get deleted and new blocks filled in. And I can do this as long as I want. The next question is, where do we take it from now on? Well, first of all, instead of just having red, green and blue cubes, you can make your prefabs basically anything. You can have power-ups, enemies, other players, basically anything you can fit in a prefab. So you're not just limited to breakout fields, you can make like a maze game or a role-playing game and place treasures, for example, based on a grid. You could extend your level format, so instead of just red, green, blue and holes, you could also specify which background music to play, which background images to use, which tile sets, and so on. So it's really, this is the basic setup, And from now on, it's just your imagination and your idea for what kind of game you want to use. As always, with my examples, you also get a C# version, which I would really recommend in this case because, as you've seen, we use some C#.NET classes, and it's just more documentation available online for text parsing. And you can even extend the format and the parser to take XML files, which allow more organization than just this. So anyway, thanks for watching and see you next time. Goodbye.